Well, if a number is composite, that means it has some smaller factor, something besides itself and 1. I could show that to you. You could do the long division and check that indeed it goes evenly into that number. So compositeness or non-primeness is clearly an NP, because if the answer is yes, it's composite, there's a simple proof. Proving that a number n digits long is prime, that's much trickier. In fact, there is a witness that a number is prime, if it is, that is easy to check. But it involves some tricky number theory, because it's not enough to show you that there is a factor. I have to show you that there isn't a factor. And again, I don't want to have to go through all possible factors, because there's a huge number of those if this number is n digits long. In fact, we learned in 2004 that primeness is solvable in polynomial time. This was one of these big events where a problem turned out to be easier than we thought it was. And there were 3 authors in the paper, and 2 of them were undergraduates. Oddly enough, we still don't know a polynomial time algorithm for factoring an integer into its smaller factors, into its prime factors, as we'll talk about much later in the course. We do know how to do that with a quantum computer, but not with a classical computer in polynomial time. So as far as we know, the factoring problem is outside P, even though the primeness problem is in P. There's a lot of interesting mathematics underlying the difficulty of these problems.